Hello everybody, welcome to part 2 of halide ions and conc sulphuric acid. Now to be more specific, this is the reaction of solid sodium halides, which I'm going to write down as NaX, and concentrated sulphuric acid, which is H2SO4. Now you have to watch the first video, which is talking about why we're doing this. And the reason to do this is we're trying to show a trend in the reducing ability of the halide ions. So, spoiler alert, we know that I- is the best reducing agent. It is the best at losing its extra electron that I'm pointing at there. It is the best at turning back from iodide into iodine. Now to make this look better, both those iodine atoms will join together, so you'll need 2 of these and 2 electrons will be released. Iodide is really good at doing this, really good at releasing electrons. Fluoride, on the other hand, is absolutely terrible at doing this. Alright, it is no good at releasing its electrons because fluoride is very, very small, so it holds on to that extra negative charge, that extra electron, really, really tightly. So iodide is the best reducing agent. Okay, so what I'm going to do here, firstly, I'm going to get you to memorize, before we go into why we're doing this, I'm going to get you to memorize a little diagram. So this is a Norton patented diagram, of which there are many. But here is one that I think helps with this topic. So firstly, what you're going to do is you're going to draw it's a set of stairs effectively. All right. So the first one I'm going to do is going to be fairly neat. It's going to be 3 blocks across, and you're going to have to do this. So you can watch me do it first and then make your own. The second step goes like this. There to there, up to there. I'm already getting more scruffy. And then the third step is actually 2 steps high. This is an incredibly important diagram that will help you in this topic. And because other schools don't teach it this way, I think it puts you in an advantage. Okay, so it looks like a set of stairs, but the top step's a little bit bigger. What this represents is chloride. So I'm just realizing my shadow is being cast over this paper. Chloride and fluoride are in this box. Bromide, so Br minus, and I minus, iodide. And what this diagram is going to show is the reactions of fluoride, chloride, bromide, and iodide with H2SO4, concentrated H2SO4. Getting a little bit wobbly. Why is that wobbling? Oh, it's going to make you seasick. See if I can get that to go flat. One sec. Yeah, there we go. Right then. So, firstly, we're just going to fill in this diagram, and then we can use it in an exam situation. All right, so I hope you realize then that iodide is the best reducing agent. So this diagram is already set up. Best reducing agent. Okay? Middle, worst. And what you can actually see here is this iodide. These boxes represent product that will form when you react with H2SO4. So what we're saying is when you react H2SO4 with iodide, you're going to make 4 different reactions will happen. With bromide, 2 different reactions will happen. And with fluoride and chloride, 1 reaction will happen. So the first thing to do is to fill out what this step is. And what this means is across this bottom section, fluoride, chloride, bromide, and iodide will all react with conc H2SO4 in the same way, which is represented by this row. And what they will do is this. the solid sodium halide, NaX, where X represents chloride, bromide, or iodide, so sodium chloride, sodium bromide, sodium iodide, will react with H2SO4, which is concentrated H2SO4, so AQ, to form. The first thing it will form is sodium NaHSO4, which is sodium hydrogen sulfate. So the Na plus will react with an HSO4 minus. You will also make HX, which is misty fumes of hydrogen iodide, hydrogen chloride, hydrogen bromide, and that is a gas. And that will be aqueous. Just checking that balances. 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. This equation across the bottom is incredibly important, and you can see that it's the same for fluoride, chloride, bromide, or iodide. So this reaction, reaction number 1, happens if you have sodium iodide, sodium chloride, or sodium bromide. So this reaction, you just got to learn this equation. I want you to memorize this equation, just like I have. I've memorized it. All right? And that represents a reaction that all of these halides do with concentrated sulfuric acid. Things to note about this reaction, and we'll talk about it later, this is not a redox reaction. All right? It is not a redox reaction. All right? Now, you can prove that to yourselves if you want to by looking at the oxidation states across here, but should I do that now? Yes, I'm going to do that now. This is not a redox reaction. I can tell this by looking at some key oxidation states. Sodium here, the group 1 metal in a compound is +1. Sodium here is +1. The halide ion here is -1, and over here it's -1 because the hydrogen is +1. So the halide is -1 here and it's -1 here. In other words, it's a halogen with an extra electron here, and it's a halogen with an extra electron here. It still has its extra electron. No redox has happened. And the most important one, I suppose, here is the sulfur was +6 over this side, and it's still +6 over this side. This is not a redox reaction, but it happens in all 3 cases. All right? Now, the next thing to know is what observations you will get with this. Now, this gas here, the HX, that's hydrogen chloride, hydrogen bromide, hydrogen iodide, will make misty fumes. And that's your observation, so I'm going to draw a pair of glasses there. The observation, the proof of this reaction happening is misty fumes of hydrogen iodide, misty fumes of hydrogen chloride. All right, you might not be following this so far. If you're not, just learn that equation. All right. If you then take a step up, what you'll notice is that is the only reaction that fluoride and chloride do. That is now finished. So if you add sodium chloride or sodium fluoride to H2SO4, you will just do this reaction. Then you go up, nothing else happens. But bromide and iodide go up and do another thing. And what they do is they will react with conc sulfuric acid to make some SO2 gas. So I'm just going to write SO2 in these boxes. You will also make some of the halogen. In other words, the bromide will become bromine and the iodide will become iodine. This is redox. Because what you've got here is the bromides have become bromines and the iodides have become iodines, 2 electrons, and the H2SO4 has become SO2, and we'll look at the half equation for that separately, but basically +6 +4. All I want you to remember for these boxes for now though is SO2, Br2, SO2, I2. I'm going to draw in this diagram out a lot. Now, that is where bromide's reactions stop. It does reaction 1, where you get misty fumes, and it does reaction 2, where you get this SO2 gas. And what you need to know is the SO2 gas is a choking gas. That's the observation. If iodine is made, you get a black solid. You might also see it as purple fumes. Oops, I have written purple fumes off to the side there, but I've run out of space. I'll just try and prove that to you. Purple fumes. So in this case, you would get choking gas. And Br2, now you might know this, it's orange, bromine. And you will often see it as orange fumes. Now, because this is in solution, you will sometimes see that as an orange solution being formed. I'm just checking, I can't remember, I haven't got my my book with me actually. Orange, 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 orange. Do they sometimes say brown fumes? Oh, that's annoying me. I'll have to check that in a minute. You get bromine forming as well. I'll have to check the mark schemes for what they want there. Anyway. And that's the end of the line for bromine. Do you get brown fumes? Oh, I wish I had my book with me. Anyway, the observation for bromine there is going to be bromine is formed, which I think we can go with orange fumes. Darn it. I'll have to look in a sec, so I'll have to pause this video and check that. All right, now we need to know what goes in these two boxes. You need to know that sulfur is also formed, and I2. And then at the very top, H2S and I2. Remembering that the I2 has been formed from the iodide, and the sulfur has been formed from the H2SO4, and the H2SO4 has also formed H2S. So there are little half equations that we can draw in here. Little things then. The observation here is sulfur is a yellow solid, and H2S, it's a shame we're not in a lab and I can show you this or demonstrate it, you would hate me for it, is an eggy smell. Alright, an eggy smell. I'm just going to move that across a bit. Alright. So that is your completed diagram. Now you don't know what you're going to do with it yet, so what I'm going to show you is I'm going to show you me drawing out that diagram again. Alright, might seem a bit weird, but that's what I'm going to do. Alright, not even using a ruler this time. Check me out, it's crazy. This diagram shows you everything you need to know for this topic, and I promise you it is incredibly, incredibly useful. Alright, so we've got chloride and fluoride. We've got bromide and we've got iodide. Alright, we're reacting with concentrated H2SO4. So an examiner might ask you, what reaction do all of these sodium halides produce? Well, actually, you just need to know this bottom reaction. So from memory, NaX, the sodium halide will react with H2SO4 to make NaHSO4 plus HX. And this will be misty fumes. I've written misty fumes. Gosh, I just need to maybe zoom out a bit. I'm going to write it here. Misty fumes. All right, that's a reaction that they will all do. So if this was NaF, you would make HF over here. Misty fumes of HF. All right, bromide will also react to make SO2 and some bromine. Iodide will make SO2 and some iodine. Iodide will also react to make S and some iodine. It will make H2S and some iodine. This is eggy smell. It's called hydrogen sulfide, which I'm sure you knew. This is a yellow solid. This is a black solid or purple fumes. This is a choking gas. This is a choking gas. This, I'm still not sure about, I think is an orange fumes or orange gas. All right, I still haven't paused the video to go and find out. I'm not going to. So then, watch this. I'm going to do it again. So it becomes quick. You go NaX plus H2SO4 arrow NaHSO4 plus HX. Misty fumes. Then you go SO2, SO2, Br2, I2, S, I2, H2S, I2. You practice, and you learn what all of these products are. So these boxes here show you the products of the reaction. So you can see that when you react iodide with concentrated H2SO4, you will make all of these. You will make misty fumes of HI. You will make a black solid. You will make a choking gas. You will make a yellow solid, and you will make an eggy smell. It is the most revolting experiment that we do in school. It stinks. It's choking. It's disgusting. If you react sodium bromide with H2SO4, you will make HBr, misty fumes. You will make a choking gas, and you will make some orange fumes. It's disgusting. If you react NaCl with H2SO4, you will make misty fumes of HCl. End of story. Which is not a redox reaction. So let's remind ourselves, not redox. The oxidation states don't change. Redox, redox, redox. All right. So what we're going to look at now is how on earth are we going to use this in an exam, and why am I teaching it to you? So your job is to learn this, learn the observations. Actually, I challenge you to go and find out what bromine looks like in these observations. You will not see this diagram anywhere. You will see something similar on Dr. Halide's notes, but this diagram is really easy to learn, really, really easy to learn, and it's totally invaluable. What you've now got to do is learn how to use it. So that's going to be part 3 of this video, going through how we can use this diagram in an exam, and why this diagram will save you hours and hours of work. I'm just going to do it one more time. All right. Firstly, you learn the shape. This is chloride or fluoride, the worst of the reducing agents. Bromide, the next worst. Iodide, the best reducing agent. What will you get if you take solid sodium halide plus H2SO4 aqueous? You will make NaHSO4 aqueous plus HX, misty fumes. You will make SO2 choking gas. In the same time, you'll make Br2, I2, black, orange. You will make S and I2, yellow solid. You will make H2S, eggy smell, stinks, up there. Do you notice how quickly it is to learn this? Not redox, 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 redox. Why is it not redox? Because no oxidation stage changing in that whole reaction. Iodide is the best reducing agent. Have a look at what I mean by that. Iodide is the best reducing agent because it can turn H2SO4 into SO2. In other words, it can reduce it from +6 to +4. It can turn H2SO4 into S, reducing it from +6 to 0. And it can take H2SO4 all the way to H2S, taking it from +6 to -2. Iodide is the best reducing agent. Iodide gives away its extra electron so easily that it can reduce H2SO4 all the way to H2S. Bromide is the next best reducing agent. Fluoride and chloride don't even act as reducing agents, because remember, this is not a redox reaction, so they don't even give up their electron when they react with H2SO4. This bottom reaction is known as an acid-base reaction. Final little thing before I go. This is sometimes, you can also make Na2SO4, but if you learn this one equation, you're laughing. Right, so I'm just going to leave that up as the final parting shot. Learn it, and we're going to use it in the next video. Oops.